All right. So we've understanding what equations are. We now understand what sorry, I'm drawing a blank. Analyzing are, and now we're gonna do the balancing equations. So balancing equations is when we figure out if both are on the correct sides. So contain the same number of atoms of each element on both sides of the equation. It is we have to obey the law of conservation of mass and energy. So energy has to go somewhere during a reaction. It either has to go endothermic or exothermic, like we talked about with the first set of notes. It either goes into the reaction to create something new, or it is exploded through out of the reaction to figure out how something is created. So with this means mass has to stay the same as well. So the number of atoms have to be consistent on both sides. So meaning with when we talked about, I mentioned a little bit in our first notes, when we have H2 plus O2 equals H2O, that's not balanced because there are less oxygens on the product side than there are on the reactant side. So we must then balance the equation. So everything has to equal out. Steps for balancing the equation. In ink, we leave room for the coefficients and we write an unbalanced equation. So we count and record the number of atoms of each side of the element. So we basically set up a little table. We look at the different elements that are in the equation. We set them up as on the left side of this table, and then we put reactant and product side or left and right side, and then we have to count up the number on the reactant side. So the reactant side is put down, and then we count up and record the number of atoms on the product side. So that means left and right. So we're looking at the arrow as our divider. As we do this, then in pencil, we use coefficients to balance the equation. So this is one element at a time, and sometimes it only takes one coefficient to balance the entire equation. Sometimes it takes 6 or 7 tries. It can be frustrating if you take your time doing it. Now, our combustion reactions are going to be ones that are a little bit tougher with things like this. So it is often best to start with an element that is not H or O. Hydrogen and oxygen are the most occurring in these reactions. So they will occur and have a lot of oxygens, carbon dioxides, a lot of hydrogens, a lot of waters that will be created from different equations. So make sure that we are balancing them last because they'll change the most throughout our balancing of our equation. Now, remember, we can never change the subscripts. So the smaller number cannot change in the chemical formula or else it changes the entire substance completely. So the only thing we can do is put numbers in front of our different elements and compounds or our products and reactants. So whenever it is possible, we reduce it to the lowest possible ratio, just like we talked about with our empirical formula. Now, with this, we don't want to have like a 10, 12, 14, and 16 because those can be reduced easily by 2 and figure out what we have. We want to keep the smallest number possible so that the ratio it does not get out of control if at all possible. Now, in principle, we use the coefficients to balance the elements one at a time. So when you're stuck on an even or odd problem, double all coefficients that you've already written, because that could be the difference. Remember that you are having to count all of the oxygens on one side, all of the hydrogens, all the carbons, all of whatever element you're looking at, because sometimes they will be a part of 2 different compounds, but you still must add them as the total number of oxygens in the equation or total number of element in the equation. So when balancing a double replacement or a single replacement reactions, you can treat polyatomic ions as if they were a single element. So thinking about when we have a double replacement, normally that is an ionic change or an ionic compound change. So you can change those polyatomics as a single element if you makes it easy for you. If not, continue to do the single element at a time problem. It might be confusing if you are not very familiar with the polyatomic ions, so you may just want to stick with the elements. That is your personal choice. So if it is possible to reduce all coefficients to the lowest possible ratio, write the ratio of coefficients for the equation. So in this case, what we will do is we'll set up our table. We will look and we will balance the equation. So on the reactant side, we have Cl2, so we have 2 Cls. And on the product side, we only have 1. On the reactant side, we have 1 Na and we have 1 Na. On the reactant side, we have 1 Br, and on the product side, we have 2. So first thing we can do is let's balance our Cls, our chlorides, or chlorines. So I'm going to put a 2 in front of this, and because now I have Cl together, I need to put a 2 in front of my Na, and I'm balanced. It's that simple, because there now I have 2, 2, 2, 2, and 2, and 2. Now I will have a spot for you to answer these in your Edpuzzle, the last 2. You will need to put your ratio, so that means actually I'll figure out a way for you guys to do it so you don't have to worry about it. But I want you to do 2 and 3 on your own, and that will be all you have to worry about for today. So let me know if you are understanding or if you are having trouble with this. If I am unavailable for you today, please let me know. I hope you have a nice day. Or if I am unavailable, I will let you know. Sorry. Have a nice day, and please contact me with any questions you have.